Let's talk about Quicksort today, and why it might be faster than other sorting methods. Consider the Smith family, which has 5 members. There's John, Mary, Jack, Billy, and Emma. Notice how they all have different heights. So we could sort them by their height from the shortest person to the tallest person. One way we can do this is by using selection sort, and it goes as follows. Go through each member on this list and determine who the tallest person is. In this case, John is the tallest. Now we move the tallest person to the rightmost. Now we go through the list again. This time, we ignore the person that we have just moved. Once again, we're trying to find the tallest person here, which is Mary. So we move Mary to the right, and now we go through the list again. And Jack is the tallest one out of the 3, so we move him to the right. Now we compare Billy and Emma, and Billy is taller, so we move him to the right. And just like that, the list is sorted. So that was just the Smith family. But what if we had more people? Would this method still work well? Now let's consider a group of 9 people, and for simplicity's sake, we'll leave them unnamed. Let's apply selection sort again. We go through each member in this list, and we determine the maximum, or the tallest person. Once we have found the tallest person, we move him to the right. Now we go through the list again, finding the tallest person and moving him to the right. By repeating this method, we can eventually sort the list, but notice how we're making progress very slowly. In fact, we have repeated a lot of the comparisons over and over again. Now for 9 people, it seems like selection sort works okay. But what if we had even more people? What if we had double, quadruple, and more? This is where Quicksort comes in handy. Let's revisit the Smith family again. Imagine that Mary had a great idea. She told all the people to her left to go to her right if they're taller than her, and all the people on her right to go to the left if they're shorter than her. John is taller than Mary, so he moves to the right. Billy is shorter than Mary, so he moves to the left. And now Emma, who is also shorter than Mary, also moves to the left. Now in a fraction of the time that it took us to sort them using selection sort, Quicksort effortlessly did the job. But once again, what if we had more people? Here we have our group of 9 people again, and just like before, we're going to select the person in the middle as the standard to compare everyone else to. For clarity, we'll mark him with a cool hat. Now we'll compare the groups to the left and to the right of the red-hatted person to him, and whenever a person in the left group is taller than him, we'll move him to the right, and when a person in the right group is shorter than him, we'll move him to the left. As you can see, we're moving this person to the right, and also this person, because both of them are to the left of the red-hatted person, and they're taller. To make it clear, we're going to mark these 2 people who are sorted separate from the right group that are not sorted. And now we can look for people who are shorter than the red-hatted person and move them to the left. Notice that at this point, the red-hatted person is sorted relative to everyone else, because everyone to his left is shorter than him, and everyone to his right is taller than him. So we'll set him aside for now. Now for the remaining 2 groups, we can apply Quicksort again and pick 2 new people to compare everyone else to. We'll mark them with blue hats. Now just like before, we're going to move everyone to the left of the hatted person who are taller than him to the right, and everyone to the right of the hatted person who are shorter than him to the left. What's great about Quicksort is that we'll never have to compare anyone in the left group to anyone in the right group, because they're already sorted relative to the red hatted person. Now we simply need to combine the sorted subgroups, and just like that, we've sorted the original group. Let's review the number of comparisons we made using each sorting method in each scenario. For the Smith family using selection sort, we had 15. But using Quicksort, we only made 2 comparisons on either side of the middle person, so it comes out to be 4. Now for the 9 people group using selection sort, we had the sum of 9, 8, 7 all the way down to 1, which is 45. But using Quicksort, the number comes out to be 16, which is almost the same as using selection sort for the 5 people group. Therefore, Quicksort is much, much faster.